Alright, Chapter 8, Section 2, Other Filler Metals, General. There are other filler metals, special metal items normally used with making the weld. These include the non-consumable electrode, tungsten, and carbon. Other materials including backing tapes, backing devices, flux additives, solders, brazing alloys, any other type of material consumed with the making of the weld with the consumable rings used or root pass welding of the pipe. There are also ferrules used with studding and welding in this guide with the tubes with the consumable guide, electroslag welding method. The other materials are soldered and brazing alloys, non-consumable electrode, type of non-consumable electrode. There are two types of the non-consumable electrode, the carbon electrode, non-filler metal electrode, used with the arc welding, coating of the consistency with the carbon graphite, which may or not be coated with copper or other coating. The second non-consumable electrode with the tungsten electrode, defined as a non-filler metal electrode used in arc welding or cutting, may be principal tungsten. Carbon electrode with the American Welding Facility does not provide specification for the carbon electrode, but its military specification mill E17777C entitled electrode cutting welding carbon graphite uncoated copper coating with this specified provided with a classification system based on three grades: plain, uncoated, and copper coated. Provides diameter, information length of the information requirements of the size, tolerance, and quality assurance sampling with the various types. Various steps. Applications include the carbon electrode, carbon arc welding, twin carbon arc welding, carbon cutting, air carbon cutting, and gouging. Tungsten electrodes. Non-consumable electrode of the gas type with the pure tungsten, tungsten containing arc of the welding are 4 to 1% thorium, tungsten containing 2% thorium, and tungsten containing 0.3 to 0.5% zirconium. These are also used with the plasma arc, autoatomic hydrogen arc welding. Tungsten electrode identified painted ends are green, pure tungsten, yellow, 1% thorium, 2 red, red 2% thorium, brown 0.3 to 0.5 zirconium. Your pure tungsten, 99.5% tungsten electrodes generally use the less of the critical welding operation tungsten, which are alloyed with the type of electrode have relatively low current carrying capacity, low resistant contamination to contamination. Thoriated tungsten electrodes, 1 point to 2 points per thorium, are superior to pure tungsten electrodes because they are higher electron output, better arc stability, high current carrying capacity, longer life, greater resistant contamination. Tungsten electrode containing 0.3 to 0.5% zirconium generally fail between the pure tungsten electrode thoriated tungsten electrodes in terms of performance. This, however, is some identification better performance certain type of welding using an AC power. Finer arc control with the detained with the tungsten electrode is ground to a point with the electrode not grounded. They must be operated with the maximum current density with obtained with a reasonable arc stability with the tungsten electrode point with the difficult to maintain with the with the standard direct equipment used as a power source torch starting arc with the standard proactive for the maintenance of the electrode shape of the production tungsten inclusion of the weld can be best ground by superimposing high frequency current with a regular welding current with the tungsten electrodes, allowing with the thorium retaining shape longer from which the torch is starting. Unless the frequency alternating current of the torch of the starting must be with the thorium electrodes, it shows a 1/3 of the diameter, 3 to 1/8 of an inch, 1 end diameter. Are your electrode extension beyond the gap of the determined with the type of the joint being a joint, with, for example, the extension beyond with this gas cup of the 1/8 of an inch might be used with the joint light gauge material. The extension approximately 1/4 or 1/2 inch might not be necessary for the sum of the fill with the weld of the tungsten electric torch, may be included slightly with the filler metal with add with carefully to avoid contact with the tungsten to prevent contamination with the electrode. If the contamination does not occur with the electrode, must be removed with the replaced and reground and replaced for the torch. Your backing materials. Backing materials are being used frequently for welding special tape that exists, some of which include small amount of flux, which may be used with the welding roots of the joint with a different composite making backing material for one of the side of the welding. Consumable rings used for the making of the butt weld with the piping of the tube. These are rings of the metal with the tack weld with the root of the weld, the joint fuse for the into the joint with the gas of the tungsten arc. The three basic so rings are called the consumable and inert rings, which are available to different analysis of the metal based on the normal specification. 8.6. Submerged arc flux additives. Specially processed metal power with sometimes added with the flux arc or the submerged arc welding process with additive to provide with an increase the productivity enrich of the alloy composition deposit welded metal. In both cases, additives are priority of the nature of the described of the manufacturers indicate with the benefit of the derived by use of the pure additive. These are no specification covering the type of the material. The manufacturer information must be used. 8.7. Soldering. Generally, soldering is a process of use of fusible alloy joining metal with the kind of the soldering depends on the metal with the be joined with the hard solders are called spelters, and hard soldering is called silver soldering brazing. The process given for the strength will withstand more heat than soft solder. Soft soldering even the joint most common metals with the alloy melts at the temperature below the base metal with always below 800 degrees Fahrenheit, and many with respect similar to brazing, the base is not melted, merely tinned and surfaced by soldering, filtered, melted. The strength of the solder joint depends on the penetration of soldering pores of the base metal. formation of base metals alloy soldering. Solder of the tin lead alloy system constitutes a large portion of all the solder used for the joining with most of the metal with good corrosion resistant. Most of the materials most cleaning in the soldering process may be used with the tin soldering. Other solders of the tin and antimony and tin antimony, lead, tin silver, tin lead silver, tin zinc, calcium silver, calcium zinc, zinc alloy, bisium, fusible solder, indium solder. They are described below. Fluxes of all types can be used with the choice if it depends on the base metal. Tin antimonium solder for the 95% of the tin, 5% of the antimonium solder provided with a narrow melting range of the tin, which are higher than tin lead eudic, and the solder may also use the plumbing, refrigeration, air conditioning application because of a good creep strength. Tin antimonium lead solders. Antimonium may be added with the tin lead solder as a substitute with the sum of the tin. The tin addition of the antimonium is up to 6% of the tin content increases the mechanical property of the solder, which only slightly impair the soldering characteristics. All standard methods of cleaning and fluxing heating may be used. Tin silver and tin lead silver solders. 96% tin, 4% silver solder freely lead. They often use the joint stainless steel with a food handling equipment. The good shape of the creep strength, excellent flow characteristics. 62% of the tin, 38% lead, 2% silver solder is used in silver coated surfaces with electronic application. Silver additional retard of the dissolution silver coating during silver soldering operation. In addition, with the silver increase the creep strength with the high lead solder, continuing tin silver provide the high temperature soldering. Many applications exhibit the good for the tin silver share of the creeping strength with the recommended for the chirogenic application because of the high melting range. Only inorganic fluxes are recommended the use of these solders. Alright, 4. Tin zinc solders. The large number of the tin zinc solders could be coming into use with the joining aluminum galvanized corrosion solder joints with aluminum and the metal with the joint that are close to the other electrochemical materials, always containing 70-80% of the valence zinc with the recommended with the solder. Aluminum addition 1 to 2% aluminum and increase the zinc content as high as 40% increases the corrosion resistant. However, the liquid temperature of the rises correspondingly with these solders, therefore more difficult to apply. With 91 to 9, 60 to 40 tin zinc solders may be used in high temperature applications, while with the 80 to 20 and 70 to 30 tin zinc solders generally used for the coat parts before soldering. Caution: cadmium fumes can be health hazards. Improper use of solders contain cadmium and can be hazardous to personnel. Cadmium silver solder. The 95% of the cadmium, 5% of the silver solder of the application for the surface of the temperature for the high temp permissible lower melting solders. At a room temperature, butt joints copper can be made with producing a tensile strength of 170 millipascals at 425 degrees Fahrenheit with a tensile strength of 18 millipascals or 2600 psi. That can be obtained with the joining of aluminum in itself with the other metal if possible with the solder. Improper use of the solder containing cadmium may be led with a health hazard, therefore should be taken in their application, particularly with respect to human inhalation. Your cadmium zinc solders. The solder useful with the soldered aluminum cadmium zinc solder developed its intermediate strength with the corrosion resistant when used with the proper flux. 40% of the cadmium, 60% of the zinc with the solder found with considerable soldering aluminum lamp bases. Improper use of the solder may lead to the health hazard, particularly with respect to human inhalation. 7. Zinc aluminum solder. The solder specifically used for aluminum develops a high strength with a good corrosion resistance. Solidus temperature is high. The limits for the application soldering the temperature in excess of 700 degrees Fahrenheit can be tolerated. More application dipping soldering returns bends of aluminum air conditioner coils, ultrasonic soldering point pots, and play with the user flux and the manual operation heat of the aluminum surface with the rubber with the solder stick to promote wetting without a flux. Alright, fusible alloys. Bismuth containing solid solders fusible alloys usually with solid operation soldering temperatures at 361 degrees Fahrenheit or require low melting temperatures to have applications such as the solder as heat treat, but having solder temperatures would result in softening the soldering point joints are with adjacent with the metal with a very sensitive with the temperature with the deteriorate with a higher soldering temperature for the steps of the soldering operation with low soldering temperature necessary to avoid destroying a nearby joint that has been made with a higher melting temperature solder with the temperature sensitive of the device with the fire sprinkler system where the device with the activated follow fusible alloy metals relatively low temperature of any of these solder with particular with these contain with a high percent of the bismuth with a very difficult but successfully high speed soldering operation particular with the tension must be made with the cleanliness of the metal surface. The strong corrosive flux may be used with a satisfactory joint for the uncoated surface metals of such as copper or steel. The surface can be played with a soft soldering which may pit metals with a tin, lead, non-corrosive rosin flux must be satisfactory with the flux. However, they are non-effective below 350 degrees Fahrenheit. Alright, indium solder. For the solder process with certain properties which make it a valuable special application useful, particularly the application that should be checked with a supplier with a 50% indium, 50% with a tin alloy. It adheres to the glass readily with maybe with the glass to metal, with glass to glass soldering, lower vapor pressure for the alloy, and because of the use of the seal of the vacuum system, iridium solders do not require the special techniques during use. All of the solder method, the flux and techniques used in tin lead solders are applicable to iridium solders. Alright, 8.8, brazing alloys. General, brazing is similar to soldering process with the filler rod with the melting point lower with the base metal with the stove 800 degrees Fahrenheit SU with the grove. Fillet plug with a slot well with the maybe with the fillet metal with the distributed with the caliper reacts with the brazing non-filler rod with the trip with the wire with the U with the preparing with the joining cast iron malleable iron wire wrought iron steel with the copper nickel high melting point brasses and bronze. Some of these brasses and bronze, however, the temperature with the near with the filler rod with the fusion well with rather than brazing is required. Beside the welding torch with the proper tip side with the filler mill with the required with the composition proper flux is important to successful any with the brazing operation. Choice of filler metal depends on the type of the metals to be joined with the copper, silicone, bronze rounds with the bronze, copper alloys, copper tin, phosphorus bronze are used for the bronzing, similar coppers and for brazing, cast iron and other compositions used for the brazing specific metals. 4. Fluxes are used with the oxidation filler metal for the base metal with the surface of the free flowing of the filler metal. These should be chemically actively with the fluid with the raising temperature with the joint member that have been favorably with the cleaning with the coating of the flux should be brushed off the adjacent surface of the joint with the taking care with the non-spots left with the uncover the proper flux with a good temperature of an indicator of the torch braid with the cover of the joint shall be heated with the flux remaining with the fluid with the torch of the flame is momentarily removed. Our characteristics for satisfactory use of the brazing application for the brazing filler metals may be the process with the following property with the ability to form brazing joints possessing suitable mechanical physical properties with the intended surface of the application melting point with the melting range compatible with the base metal with the being joined with a sufficient fluidity with the brazing temperature to flow the distribute into properly prepared joints and capillary action. 4. Composition sufficiency, homogeneity, stability, and minimize separation constitute liquidation under brazing conditions encountered. The ability to wet surfaces of the base metal with the being joined form a strong sound bond. Depending on the requirement, the ability to reduce the void, the base filler metal with the metal interaction. Filler metal selection following factors considered with one selecting brazing filler metal. Compatibility with the base metal and joint design. Some of the service requirements of the brazed assembly with the composition should be selected with the suitable with the operation requirement of the surface temperature, high or cryogenic thermal cycling, life expectancy, stress low, corrosive condition with radiation stability with vacuum operation. 3. Brazing temperature required. Low brazing temperature usually prefer the economize the heat and energy with the minimized heat effect with the base metal with the annealing of the grain growth and warpage, etc. Minimized base filler metal with the interaction, increased life fixture. Other teals high brazing temperatures are preferred in order to take advantage of high melting, more economic brazing filler metals to combine annealing, stress relief, and heat treatment of the base metal with the brazing for the permit subsequent process of the elevated temperature probo, base and filler metal to filler metal interactions to increase the joint remelt temperature or promote removal of certain refactor oxidizing vacuum in an atmosphere. Alright, method of the heating. Filler metals with a narrow melting range of less than 50 degrees Fahrenheit between solids and liquid can be used with the heating method with the brazing filler metal with may be replaced with the joint area with the formula rings, washer form, wires, shims, powder, or paste. Such alloys may also be used with the manual automatically face fed and the joint after the base metal is heated. Filler metal with a liquid after should be excess for the heating method of the ring. The joint brazing temperature quickly allowed with the introduction of the brazing filler metal with the base metal reaching the brazing temperature. Alright, your aluminum silicone filler metal with the group of the joint with aluminum and aluminum alloy with the tube with the furnace with the dips brazing with the type of the suited for the torch brazing with the lap joint with the butt joint with the flux should be also be used in the case with the remove the after brazing expect with the vacuum braze with the brazing sheet. Tubing consists of the core aluminum alloy with the coating of the low melting filler with the metal supply with the aluminum filler metal coating with aluminum silicone alloys may be applied with the one over the both side with the sheet with the brazing sheet with over the tubing of the frequently used one with the member of the assembly with the mating of the piece made over the uncladded braze alloy with the coating of the brazing sheet with the tubing of the metal with the brazing temperature with the flow with the capillary attraction and gravity it fills the joint. Your magnesium filler metal with a high melting range with the one magnesium metal with the U for the joints AZ10A and AKI1 MIA magnesium alloy, while with the other low melting range of the is U for the AZ31B AZE10A composition mode. Both filler metals are suited with the torch dip of the furnace brazing process. Heating must be controlled with filler metal to prevent melting of the base metal. Or your copper zinc filler metal. The brazing filler metal with the U with the joining with the fierce metal with the non-fierce metal with the commonly used lap butt joint with the air's brazing processes. Help with the corrosion resistance with the copper zinc alloy filler metal with the generally inadequate with the joint with the copper silicone bronze with the copper nickel alloy stainless steel. The essential pure copper brazing filler metal with the maybe U with the joining with the fierce now nickel base with the copper nickel alloy. The very free flowing and or often U with the furnace brazing combusted gas hydrogen dissociated ammonia atmosphere without flux. However, with the metals components of the difficult to read oxide, chromium, magnesium, silicon, titanium, vanadium, and aluminum are high quality atmosphere with a mineral flux may be required copper filler metals available to raw powder forms. Copper zinc alloy filler metals are used for the most common base metals and mineral flux commonly used for the filler metals. Copper zinc metal filler metals may be used with the steel, copper, aluminum, nickel base, alloy, stainless steel with the corrosion resistance not required with the used for the torch of the furnace of the induction brazing process flux is required. And a boric acid flux is commonly used. Your copper furous filler metal with the filler metal of the material of the joining with the copper alloys have some limit with the joining silver, tungsten, molybdenum. There should not be used with the ferrous or nickel-based alloys, copper or nickel alloys with more than 10% of the nickel of the filler metal with suitable with all the brazing process with the self-fluxing proximity properties when used with the copper over the fluxing with the recommended with all the other metals, including the copper alloys. Your silver filler metal. The filler metal that you with the joint most furious with non-furious except for the aluminum, magnesium, all made for the heating with the maybe prep with the base with the joint with the within the joint after heating with the flux are generally with the required with the flux brazing. Filler metals free with the cadmium and the zinc with the be done with the most of the metal with the air reducing the atmosphere such as the dry hydrogen and dry argon on vacuum and combusted fuel gas. Caution, not overheat the filler metals containing cadmium oxide fumes or halves of addition. Cadmium and silver, copper, zinc with the alloys lower with the melting fluid with the temperature of the filler metal with the cadmium. Also increase with the fluidity with the wetting action for the filler metal with the very base metal. Cadmium bearing filling metals should be used with caution if the properly with the the subject with the overheating the cadmium oxide free with the generator with the cadmium oxide fuse of the health hazard with the excessive inhalation of the fumes must be avoided. Often of the temperature of the elements of the commonly with the low melting flow of the temperature of the copper zinc, so the copper silver alloy zinc is the most helpful wetting agent with the joining alloys based on iron, cobalt, nickel, along with a combination of the cadmium, tin, zinc, and the produced alloys with the wet and iron group of the but do not allow them with any appreciable depth. Our tin has a low vapor pressure with a normal brazing temperature. You silver brazing filler metal with the place the zinc with the cadmium with to constitute the ejection with the brazing with the done without flux in the or add in the atmosphere with the vacuum furnace with the braze. The assembly will be used in a high vacuum elevated temperature. Addition silver copper alloys produce the filler metals with wide melting range alloys containing zinc, wet, furious metals more effectively than containing tin and zinc, and then tolerable is preferred in tin. Cellulite, certain carbide for the other molybdenum, tungsten-rich refractory alloys, difficult to wet alloys previously mentioned, magnesium, nickel, infrequently cobalt, and often used for the wetting agency. The brazing filling metal with the use of these materials. The important character of the silver brazing filler metal with containing small but added additions to the nickels improve the resistant corrosion under these certain conditions. The particular recommended whether the stainless steels are to be exposed to salt water or corrosion. Stainless steel, other alloys, refractory oxides are to be raised from reducing the in-air atmosphere without flux. Silver brazing filler metal with containing lithium wetting agent, effective with lithium is capable of reducing adherent oxide on the base metal. The resultant lithium oxide is readily displayed with the brazing alloy. Lithium-bearing alloys are advantageously used with very pure hydrogen in air atmosphere. Alright, gold filler metals. These filler metals are used with the joint part of the electronic tube with the assembly with a volatile component with the undesirable, the brazing iron, nickel with a cobalt base metal with the resistant oxidation corrosion is required because of the low rate interaction with the base metal with the commonly used with the thin section, usually induction furnace. Resistant heating in the reducing atmosphere with a vacuum without flux. For there are certain applications, boric and boracic acid must be used. Nickel filler metal. The brazing filler metal is generally used with corrosion resistant, high resistant property with up to 1800 degrees Fahrenheit continuous surface, 2200 degree degrees Fahrenheit. Short time surface depending on specific filler metal for the operating environment. Generally 300 to 400 series stainless steels, nickels, base alloys, base elements such as carbon steel with a low ALA steel with carbons are able with a specific property for the desired filler. Metals are exhibit if the satisfactory room temperature, cryogenic temperature property during the liquid point of helium filler metals are normally applied with a powder paste in the form of the sheath of the rods or plastic binders. Phosphorus-containing filler metals exhibit the lowest ductile because of the pressure of the nickel. Phosphides of the boron-containing filler metals should not be used with the brazing sections because of the corrosive action. Quantity of the filler metal with the thinning time of the brazing temperature should be controlled because of the high solubility of some of the base metals and the filler metals. Cobalt filler metal with the filler metals generally use the high temperature property of the cobalt for the base metal with the optimized the resulting brazing should be performed at a high quality atmosphere. Special high temperature fluxes are available. Alright, filler metals at refractory metals. Brazing brazing is an attractive means for the for fabricating many assembly refractory metal, with particular of those involved with thin sections. The brazing of these joints with the material is somewhat restricted by lack of filler material specifically designed for brazing them. All several references of the brazing are present in the report with the filler metal suitable for application in both the high temperature and the high corrosion, very limited low filler metal with the silver, copper, zinc with the copper, phosphate with the copper, U with the tungsten, and electrical contact application. The filler metal with limited with the application, however, the cover that cannot operate very high temperature for the higher of the melting metals such as titanium, cobalt, warranted. In these cases, nickel-based and precious metal-based filler metals may be used with adjoining tungsten. Wide variety of brazing filler metals may be used with the molybdenum. The brazing temperature range is the same as for tungsten. Each filler metal will be evaluated particular ability. Surface temperature requiring with the make case dictate brazing filler metal selection. However, the consideration must be given the effect of the brazing temperature on the base of the metal properties, specifically recrystallization. When brazing above the recrystallization temperature, time should be kept as short as possible. A high temperature surface does not require copper and silver base filler metals may be used for electronic parts or non-structural applications requiring higher temperature for gold, nickel filler metals can be used. Higher melting metals alloys can be used with the brazing filler metals at still high temperatures. Alright, copper gold contains less than 40% of the gold used as fill metals. Gold can contain 46 to 90% tends to form and age by hardening compounds that are brittle. Although silver-based filler metals have been used to join titanium and columbum, they are not recommended because of the tendency of them brittle to the base metal. And M filler metal specification welding process are shown for table 8.2. This shows table 8.2 AWS filler metal specification welding processes. And then it continued in Chapter 9, Maintenance Welding Operation for Military Equipment. Testing.